Hello, I'm Dawson Wiseman. I'm an undergrad student at Oklahoma State University, and I'll be presenting our project, Lightweight Deflectometer for Deflection Modulus-Based Compaction Control. I'm working with the grad student Ravi and Dr. Mishra. To introduce our project, the nuclear density gauge is used to measure density and compaction of soils currently. However, it is not directly related to pavement design and also is hazardous and has special training that needs to be taken into consideration. If there was a way to measure the modulus directly, that would be preferred, and we believe that LWD has that possibility. Our research will have 3 phases: laboratory testing, numerical modeling, and a full-scale testing. In the past, soils have been tested or compacted with the Proctor molds, and in this research we will use ASTM number 4 and ASTM number 57 aggregate. With the soil is compacting the Proctor mold. Every agency uses a Proctor mold, and that way if we can use the LWD as well in a Proctor mold, then there is less of a need to buy new equipment and is more convenient and efficient for testing. We can see that the LWD modulus is consistent with the resilient graph. It is fairly linear. With finite element modeling that we are doing, we can see in this graph that the results are very similar to the results that we're getting in the lab, our actual results. Our lab work will be using 2 different Proctor molds, a custom 12-inch diameter and a custom or a regular 6-inch diameter mold. The heights will also vary from 11.5 inch and 4.6 inch. In the far right, you can see that our LWD testing is having consistent results. However, the modulus is a little low because our compaction is not correctly compacted in the soil. We're using 2 different LWDs, an Olsen one and a Zorn one. In this data, you can see that the results from both LWDs are consistent and follows very similar paths. We are also testing to make sure that the LWD will remain consistent in certain locations that are changing. In this graph, we can see that it isn't, and we will need to standardize our testing to account for that. After our first stage of testing, we will move to our second stage, which will be a big wooden box that we will compact with a modified jackhammer and then run the LWD test on that. Our final stages of the project will be a full-scale model on our campus, and we'll build an entire road. To summarize our research, we're hoping that the LWD will provide a modulus that can measure compaction in the field more consistent than nuclear gauge testing.